discussing the topic of laser. As you all can see, here L stands for the light, amplification by stimulated emission of radiation. So light amplification by stimulated emission of radiation is nothing but laser. Now there are various types of lasers available in the market. In order to learn or in order to understand the energy level diagrams of various laser, we must know these three transition processes, namely stimulated absorption, spontaneous emission and the stimulated emission. Stimulated is nothing but the force and spontaneous will be by its own. As you all can see, I have drawn two levels in all the three cases. The energy of the lower level is E1, the energy of the upper level is E2. In order to learn or in order to understand what is the stimulated absorption, consider an electron is initially present in the lower level of energy E1. Okay. Suppose if you send one photon inside the system having energy h nu, which is exactly equals to the difference E2 minus E1. Now one electron can absorb only one photon at a time, so this electron will absorb this photon, and with the absorption of this photon the electron can make an upward transition because the energy gained by the electron is exactly equal to the difference between these two levels. So as you all can see, initially electron is present in the lower level. With the absorption of photon, the electron is making an upward transition. So we are forcing an electron to make an upward transition by supplying some energy. Hence the process is known as stimulated absorption. Now if you denote A as the ground state position of an electron, so this electron which is present in the lower level will absorb an energy h nu. And as a result you will see the same electron in the upper level, that is the excited level E2. The position of an electron in the upper level is denoted as A asterisk. Okay. Now let us learn what the second process is. It is spontaneous emission. Now for emission process, whether it is spontaneous or stimulated, initially the electron must be present in the upper level. So let us consider for spontaneous emission process the electron is present in the top level. Now the upper levels are non-equilibrium level. Electron will not prefer to stay there for a longer time. So the electrons which we are sending in the upper levels by supplying some energy, electron will not stay there for more than 10 raised to minus of 8 seconds. Okay. So this electron will immediately come back to its lower level, which is the ground state even. Now while making this downward transition, the electron will release a photon of same value h nu, which is equals to A2 minus even. So spontaneous emission is the one in which excited electron will come back to the lower energy level with the emission of a photon. So if you want to design an equation, the initial state of an electron is the excited state, which we will denote as A asterisk, and finally this electron will lose a photon of energy h nu, and you will find the same electron back in the lower level, which is the de-excited position A. Now the third and the very important process as far as the laser action is concerned is stimulated emission. The word stimulated stands for the forced reaction. Electron is present in the upper level. Now there are certain excited states where an electron can spend more than 10 raised to minus 8, that is, let's say 10 raised to power of minus 3 seconds. So electron can stay here for a time of 10 raised to minus 3 seconds. Such states are known as a metastable state. Now since electron is present in the upper level, so electron is already having one photon of energy h nu. Now suppose if you send one more photon of energy h nu, which is also equals to A2 minus even. Now this second photon will trigger this electron to make a downward transition. But in this transition, instead of one, this electron will release two photons. One photon which was absorbed during the upward transition, and the second photon which is acting like the triggering agent. So as a result, you can see there are two photons released in the process of energy h nu. Such a process is known as the stimulated emission. If you want to design an equation, initial position of an electron is the excited position. You are sending one photon inside the system of value h nu. This is acting like the triggering photon. As a result, electron will come back to the de-excited level A, and in this process 2 photons of energy value h nu are released. Such a process is known as a stimulated emission. So as you all can see, we have discussed 3 processes: stimulated absorption, spontaneous emission and the stimulated emission. After this, we also have to discuss the equations of the rate of the processes. So the rate equation, rate of any process is denoted as R. So everywhere I will write R, but in order to differentiate, here I will write R suffix AB, it is the rate of absorption, R suffix SP, it is the rate of spontaneous emission, and R suffix ST is the rate of stimulated emission. Let us consider N1 is the number of electrons in the lower level and N2 is the number of electrons in the upper level. Now rate of absorption depends on how many electrons are present in the lower level. So for this I require N1. The second and the third process depends on how many numbers are initially present in the upper level. So therefore you will write N2 over here, N2 over here. Now as far as your first and the third process is concerned, you require some external photons. So your first, that is the rate of absorption, depends on rho, which is a function of nu. Now this rho is the density of external photon, which is the function of its frequency. Similarly, your third process also depends upon the density of external photon, rho, which is a function of nu. As far as your second process is concerned, you don't require any external photon, hence we will not multiply by a factor of rho. Now, very important, you also have to include Einstein's coefficients in this case. Now, if your process is stimulated, the coefficient used is B. Here also the process is stimulated, so the coefficient used is B. But if your process is spontaneous, the coefficient used will be A. Now you also have to add the suffix to these coefficients. In the first process, the electron will move from first level to the second level. So B suffix 12. What is B suffix 12? This is the Einstein's coefficient for stimulated absorption. In the second, that is spontaneous emission, electron will jump from 2 to 1. So this is Einstein's coefficient for spontaneous emission. And in the third process, an electron will move from second to 1. So this is also an Einstein's coefficient for stimulated emission. So likewise we have 3 rate equations: rate for absorption, rate for spontaneous emission and the rate for the stimulated emission process. What is B suffix 12? Einstein's coefficient for stimulated absorption. What is A suffix 21? Einstein's coefficient for spontaneous emission. And what is B suffix 21? This is the Einstein's coefficient for stimulated emission. We require all these 3 equations, that is the equation for the rate, in order to derive the relation between the Einstein's coefficients.